Analysis of optimal deployment of several DGs in distribution networks using plant propagation algorithm. So now coming to the introduction part. In the subsequent sections, we delve into the methodology, problem formulation, experimental setup, and findings of the study, contributing to the broader understanding of optimizing DG placement and the application of nature-inspired algorithms in power distribution systems. This analysis delves into the application of the plant propagation algorithm to the optimal deployment of multiple DGs in distribution networks. Through a series of experiments and simulations, the effectiveness and efficiency of PPA in finding near optimal solutions for DG placement are evaluated. So now coming to the objective part for this project is to investigate and assess the effectiveness of the plant propagation algorithm in optimizing the deployment of multiple distributed generation units within distribution networks. The deployment of DG systems presents a complex optimization challenge as it involves determining the optimal locations and capacities of DGs to achieve various systems objectives such as minimizing power losses, voltage variations, and enhancing system reliability. The application of PPA to this problem systems from its unique inspiration drawn from the growth and the propagation of plants in nature. Overall, the paper presents a novel and effective approach for the optimal deployment of DGs in distribution networks. The proposed algorithm is simple to implement and can be easily adapted to other distribution networks. So now coming to the requirements part, we have two types of requirements, that are hardware requirements and software requirements. In hardware requirement, operating system as Windows is required, processor i5 and above, minimum 4 GB of RAM is required, hard disk 20 GB and above. Coming to the software requirement part, Python IDE and the 3.7 version is required. So now coming to the methodology part, first upload dataset. This first step is to upload the dataset of power losses to the PP algorithm. The dataset should contain the following information, that are the active power losses at each bus in the network, the voltage at each bus in the network, the location of the distributed generators in the network. Second, we have pre-processed dataset. The second step is to pre-process the dataset. This involves removing any outliers and noise from the dataset. It also involves normalizing the data so that all of the values are on the same scale. Third, run PPA algorithm. The third step is to run the PPA algorithm. The algorithm will find the optimal locations for the DGs in the network to minimize the total power losses. Fourth, improve the voltage profile graph. The fourth graph is to create an improved voltage profile graph. This graph shows the voltage at each bus in the network after DGs have been deployed. Fifth, active power loss graph. The fifth step is to create an active power loss graph. This graph shows the total power losses in the network before and after the DGs have been deployed. So now coming to the execution part, to execute the project, first we need to open the code folder. So here we have a folder which is named as dataset. In this we are containing a dataset over in the .csv file. And this PPA is a Python file which is contained in the Python script variant. And here this is the run.bat file. Instead of executing the program in command line interface, we created Windows bat file to execute the project. So now to run the project, double click on run.bat file to execute the project. Here this is the graphical user interface. With this we are interacting with the program. Now click on upload dataset button to upload the dataset. Here I am selecting this dataset and now click on open button to load the dataset. So here on this screen you can see that the dataset has been loaded over here. We can see dataset contains numerical values, and also to remove such values, now click on pre-process dataset button so that the dataset can be pre-processing. After pre-processing dataset, we selected latitude, longitude, bus number, voltage, frequency and point which contains power line coverage, latitude and longitude. Now dataset is ready, and now click on run PPA algorithm button to apply PP on dataset and to calculate power loss and voltage. Here on this screen you can see that after applying PPA, whatever best DG selected are showing with their latitude and longitude location, and in below we can see power loss value after applying PPA and power loss value without applying PPA. We can see after applying PPA, power loss reduced to 7.36 and without applying PPA power loss was 10.16. So now click on improved voltage profile graph button to get the graph. Here in this graph you can see that x-axis represents bus number and y-axis represents voltage value. And in this graph you can see that blue line represents DG and PPA, and here orange line represents without DG and PPA in this graph. Voltage life improves when we apply RPA. So now closing this graph. Now click on active power loss graph button to get the graph. So here in this graph you can see that blue line represents over here with DG and PPA, and orange line represents without DG and PPA. From this graph we can see after applying PPA power loss reduced compared to non-applying PPA technique. So now close this graph. So now coming back to the conclusion part, the PPA is a promising algorithm for the optimal deployment of DGs in distribution networks. The algorithm is able to find the optimal deployment of DGs that can significantly reduce the total active power losses and improve the voltage profile of the network. The algorithm is statistically better than other algorithms in terms of both technical and economic performance. The algorithm is simple to implement and can be easily adapted to other distribution networks.
For updates on latest project videos, please visit True Project's YouTube channel and subscribe.